Just write in the chat box. Okay. So today we are going to start a new subject uh, named as computer network, and it is very important subject as far as your RTO examination is considered. Let me share my today's presentation slide. Just a minute. Is this slide visible to all of you? Just write in the chat box so that we can proceed further. Okay, so let's start. Um, so the subject name is computer network, and this is the code 6EC402. This is the code for this subject, and this is the syllabus of the subject according to RTU. So let me briefly discuss the syllabus first so that you can understand it somewhat. What are the units of the subject and what we will going to study in these units. So the syllabus is divided into 5 units from first to unit fifth, and in the unit first we are going to study the queuing theory. So basically, queuing theory is not the part of computer network, but it forms the basis for the computer network to some extent. And in the queuing theory, we are going to study some mathematical models, their derivation and also their applications in the real world. So the some popular mathematical models which we going to study in the queuing theory are mm/1 model, mm/infinity model, mm/m model, and these are some of the popular models which we are going to study in the unit 1. And there is another important formula known as the Little's formula, which we're going to study and their applications. Now our computer network subject basically starts from the unit 2. As you can see here in the syllabus, its name is Introduction to Computer Network and the Internet. So basically our computer network syllabus starts from here, and here we are going to study some protocols which are based on the application layer. So, as we already know, there are some protocols which are very famous related to the internet. So, these are the HTTP protocol, the file transfer protocol, the email, the DNS. These protocols are very much popular. The socket programming, as you can see here, the sorted programming is also there. So these are the protocols which we are used while we are using the internet. So these protocols are basically working on the application layer. So we are going to study these protocols in when we are studying the unit 2. The unit 3 consists of another layer of the TCP IP protocol model, which is known as the transport layer. And in the transport layer, the two popular protocols which we going to study are the UDP, means user data transfer protocol, and the TCP, means transmission control protocol. So these two protocols are very much important as far as the transport layer is considered. In the transport layer, its main task is to transport the data, the information from the sender to the receiver. So these two protocols are much more important. In the case of UDP protocol, it consists of connectionless services, whereas in the case of TCP protocol, it consists of connection-oriented services. So that we will going to study when we study the unit 3. In the unit 4, we will going to study the network layer. This is very important layer because the IP version 4, the IP version 6, which we are using, is basically dealt with the network layer. So in this unit we are going to study the routing protocols, the internet protocol, what is the use of router, the internetworking devices and its two networks, which is virtual circuit network and the datagram network. So we are going to study these in details when we are going to study the unit 4. In the unit 5 we are going to study the link layer. So link layer is basically dealt with the MAC address, uh, because every system is having a different MAC address. So in this we are going to study the Aloha protocol and the IEEE 802 standards. And in the IEEE 802 standard there are many protocols which we are going to study here. We also study here the local area network, the networking devices like Ethernet, hubs, switches, and their functions. So, uh, this is how briefly I explain you the syllabus. All of you understand it? Just write in the chat box so that we can move further. Okay. So we are going to start with the unit 2 because it is introduction to computer network. So moving to the next slide. So these are some of the reference books related to the subject. So the first book is Brijon A. Forozen. The name of the book is Data Communication and Networking, and then it belongs to the McGraw Hill publication. The second book is known as the Bible of Computer Networking, which is um, written by the author Andrew S. Tenenbaum, and its name is Computer Networks. So you can take any of its edition, from fourth edition onwards. You can take any of its edition. The other important book is William Stalin's. The name of book is Data and Computer Communication, which is written by William Stalin's, and you can go through the eighth edition, which belongs to the Pearson Education. The last book is written by Douglas E. Comer, and its name is Computer Network and Internets, and it belongs to Pearson Education. So all these books are available in our library. You can take the books, and its ebook is also available in our library. So you can take the books, any four of the books, any you can take it. So let's proceed to the next slide. Just a minute,
Sir?
some other participants are waiting.
Yes, sir.
If you have any question, you can write it in the chat box. Yes, Aditi, you have any question? Just write in the chat box. Screen is not visible clearly. Just a minute. Now the screen is visible to you. Just write in the chat box. Okay. So let's start with this subject. So as you can see on your screen, the computer network is basically dealt with or based with the two models. So first model is the OSI model, and the second model is the TCP/IP model. So as it is clearly shown on your screen or in the slide that the OSI model consists of these 7 layers from first to 7, and these layers are specific, means they are having specific purpose, means the physical layer has its own feature, the data link layer is having own feature, and they are being numbered from first to seventh, and each are having a specific purpose. So you can remember the names of the layer. If somebody is asking you what is the fifth layer of the OSI model, then it is the session layer, which is the fifth layer of the OSI model. And if someone is asking which is the third layer of the OSI model, then the network layer is the third layer of the OSI model. Then the TCP/IP model, which we are using in the internet nowadays, mm, it consists of 4 layers. So as you can see on your screen that it consists of 4 layers. So the data link layer and the physical layer of the OSI model are clubbed in the link layer of the TCP/IP model. The network layer is same as is doing the same function as the internet layer of the TCP/IP model. The transport layer of both the models are doing the same function, and the application layer of the TCP/IP model consists of the 3 layers of the OSI model. Means here the application layer of the TCP/IP model is doing the same function of the 3 layers, like application, presentation, and session layers of the OSI model. So TCP/IP model it consists of 4 layers, and the syllabus of the computer network is being divided uh, the with the 4 layers of the TCP/IP model. With the unit 2, means unit 2, we are studying the application layer. In the unit 3 we are going to study the transport layer. In the unit 4 we will going to study the internet layer or the network layer, and in the unit 5 we will going to study the link layer. So all the units are covered with the TCP IPM model layers. So all of you understand it till now? Just write in the chat box so that we can proceed further. That's how the arrangement of the units are done from your syllabus. So first we are going to study the application layer. The as unit 2 consists of the application layer. Just write in the chat box so that we can proceed further. Okay. Now it's very important to understand what is the difference between the OSI model and the TCP/IP model. So there are certain points on which they are different. First is the OSI refers to the open system interconnection. It is the full form of OSI, open system interconnection, whereas TCP refers to the transmission control protocol, whereas IP refers to the internet protocol in the TCP IP model. The second difference is OSI has 7 layers, and whereas TCP IP has 4 layers, which we already studied. Then the third difference is OSI developed model, then protocol. So here model is developed first, and after that protocols are developed. Whereas in the case of TCP/IP, we developed the protocols first, and then from those protocols the model was developed. It's a very important point to understand that here the model is developed first in the OSI model, and after that protocols, whereas in the TCP/IP model protocols are developed first, and after that we develop the model. The fourth difference is OSI is less reliable, whereas in the case of TCP/IP it is more reliable. And reliability is the major concern while we are using the internet. So that's why TCP/IP model finds its use than the OSI model. So the fifth difference is OSI uses different session and presentation layers, which we already see, the fifth and the sixth layers of the OSI model. Whereas TCP/IP uses both session and presentation layer in the application layer itself. As we already see that the application layer also clubs the session and presentation layer of the OSI model. The next difference is that in the OSI model, protocols are better covered and is easy to replace with the change in technology, because here the model is developed first and after that protocols are being included in it. So as the change in technology occurs, the newer protocols can be added to the OSI model, whereas in the case of TCP/IP model, as protocols are developed first, so protocols cannot be replaced easily in the TCP/IP model. So remember this point also. The next point is in OSI model, transport layer provides assurance delivery of packets. As the transport layer works is to send the packet from the sender to the receiver. So in OSI model, it provides the assurance delivery of packets. But in the case of TCP/IP model, the transport layer does not provide assurance delivery of packets. So the packets can be reached or not reached. Uh, as it provides both the connections. With the TCP, it provides the connection oriented protocol, whereas with UDP, it provides the connection-less protocol. So sometimes the packets are not received from the receiver. So the next difference is connection-less and connection-oriented. Both services are provided by network layer in the OSI model, whereas in the TCP/IP model, network layer only provides the connection-less services. So, in order to faster the communication, we need connection-less services. As these services, as internet is as we are running the internet, and internet is an example of connectionless services. So connectionless services are very much important, but uh, in the case of OSI model, it deals with connection oriented services as well. So these are the important differences of the TCP/IP and the OSI model, which you need to remember, because a 2 mark question can be asked from this topic. Now moving to the next slide. Now the question arises, the definition of computer network. So a computer network is a group of computers linked to each other that enables the computer to communicate with another computer and share their resources, data, and applications. So this is very important, that a computer network formed from the group of computers. And the purpose of computer network is to share the resources among computers, like resources, data, and application. So this is the simplest definition of computer network. So computer network can be classified into two types. First, according to range, as you already know that you already heard that LAN, MAN, and WAN means local area network, metropolitan area network, and wide area network. We will going to study this in detail in the later slides. And the second difference, or the second categorization of network, is according to topology. Topology means how the networks are connected, or how the systems are connected. So there are certain topologies like mesh topology, bus topology, star topology, ring topology, tree topology. So these are some of the examples of topology through which the computer systems are connected in a network. So the computer networks are classified according to the range and according to the topology. So let's start with the according to range. So moving to the next slide. So here I'm just comparing it. So as you can see here in the table, the a key point of difference is there, and LAN, MAN, and WAN are given. So the definition, first point is definition. So LAN stands for local area network, MAN stands for metropolitan area network, whereas WAN stands for wide area network. Then the ownership. The next point is ownership. So LAN is often owned by private organizations, whereas MAN ownership can be private or public. In the case of wide area network, it can be owned by private or public. Then in the terms of third point is speed. So as the LAN network is small, so LAN speed is quite high. Whereas in the case of man speed is average, means it is the speed of man is between the LAN and WAN. WAN speed is slower than that of the LAN. Then the fourth point of difference is delay. So network propagation delay is short in LAN. Delay means when uh, the time between the sender send the packet and the receiver receives the packet. So delay is short in LAN because the computers are connected in a shorter space, whereas in the case of man, network propagation delay is moderate in the case of man, and network propagation delay is longer in the case of wide area network. Then the fifth point of difference is congestion. So LAN has low congestion as compared to WAN. Mm, because very limited persons are using the LAN, whereas MAN has higher congestion than LAN, whereas wide area network has higher congestion than both the the MAN and the LAN. The sixth point of difference is fault tolerance. So fault tolerance of LAN is higher than WAN. Fault tolerance means the ability to find out where the fault actually occurs, or where the fault actually exists. So fault tolerance of LAN is higher than WAN, whereas fault tolerance of MAN is lower than that of LAN, and fault tolerance of WAN is lower the than both LAN and the MAN. Then the last point of difference is maintenance. So designing and maintaining LAN is easy and less costly than WAN. Whereas in the case of MAN, designing and maintaining WAN is complex and more costlier than LAN. And in the case of here, it is you can consider is at man, and the designing and maintenance of WAN is complex and more costly than both LAN and man. So these are the important key differences between the LAN, man, and WAN. So all of you understand it? Just a minute. Amisha is asking the congestion. So just a minute. I am repeating the congestion one. LAN has lower congestion. LAN has low congestion as compared to WAN because only limited persons are using the LAN, so the congestion is limited. Whereas in the case of WAN, higher congestion than LAN, and in the case of WAN, higher congestion than both the LAN uh, and WAN occur because many persons are using the channel at the same time. So the congestion actually becomes higher in the case of WAN and it becomes lowest in the case of LAN. So all of you understand it? Just write in the chat box so that we can proceed further. Okay. Now moving to the next slide. Now we can categorize the computer network in terms of the topologies. So as you can see on the slide that there are different topologies in which the computer systems are connected. So as you can see here, uh, this is common bus topology. So in this type of topology, a common bus is there, means this cable is there, and through this common cable uh, the the systems are connected. As you can see, through the common cable, some systems are connected below the cable, and some systems are connected to the upper part of the cable. So this is called as the bus topology. And then the mesh network topology. So in the mesh topology, the systems are connected to each other through the common link. So as you can see here that this system is connected to this system is connected to this system, and the connection takes place through their dedicated links. So these systems are connected with this link. These two systems are connected through this link. So the systems are connected through other system through dedicated links. Means separate links for every system connection. Then comes across the star network topology. So here a common uh, means a common hub or router is there to connect all the systems. So this is more or less type. This is the type of the, you can say, the server is there and all the clients are connected through this server. So this type of topology is called as the star topology. And this type of topology is called as the ring topology. So in this type of topology, every system, suppose we are taking this system, then this system is connected to this system, and on its left, and this system to its right. So basically, so every system is having its left neighbor and the right neighbor. So in the same way, they form the ring. And finally, this is an example of fully connected network topology. So in this fully connected network topology, so every system is connected to every other system through a dedicated link. So this is the extension of the mesh topology. So in the mesh topology, only those links are provided through which systems are connected. But in the fully connected network topology, every system is connected to every other system in the network. So these are some of the important network topologies through which computer systems are connected to each other. So all of you understand it? Just write in the chat box so that we can proceed further. These are some of the popular topologies through which systems are connected. Okay. So moving to the next slide. So here we done the comparison between some of the popular topologies. So the first point is structure. So in the case of bus topology, there is a single central cable backbone. As we already seen in our last slide, that there is only a single controller, and all computers and other devices connected to it. In the case of bus topology. So in the case of ring topology, all computers and other devices are connected in a circle. Every system is having the its left neighbor, and every system is having its right neighbor. In the case of star topology, there is a central host, and all nodes are connected to it, as we already see in our last slide. So this is the structure. The second point of difference is host existence. So in the case of burst topology, depends on network needs. So how many hosts will be provided? It depends on the network needs. In the case of ring topology, it depends on network needs, and in the case of star topology, actually the controller is playing the role of the host because it is controlling all the other systems. The third point of difference is connection between nodes. So in the case of bus topology, it has no connection between the nodes, because all the computers are connected to a backbone cable, and there is no connection or dedicated connection between the two computers. In the case of ring topology, the system one system is connected to its left neighbor and its right neighbor. So there is a connection between the two computers. In the case of star topology, there is no connection between the two computers because all the computers are connected to the central controller, and the central controller is then connected to all the systems, but there is no connection between the two computers. Then in the next point of difference is host failure. So in the case of bus topology, network can still run even if the host fail, because all the systems are connected to a backbone, and until and unless there is some problem in the backbone cable, the other system can communicate with that backbone cable. In the case of ring topology, network will fail. Here also network will fail, as the host will fail, because it forms a ring, and if there is some problem in the link, then the whole network will fail. And in the case of star topology, if the central controller is fail, then all the communication will not be done. In the case of node failure, so in the case of bus topology, network can still run. It does not get affected by the node failure. In the case of ring topology, network will fail because here it forms the ring, and if any node is fail, then the whole ring will not work. In the case of star topology, network can still run because only one node is failed, and all the other nodes and the central controller are working correctly. So in that case, network can still run. Only that link is not working, which is having the node failure. Then the next point of difference is ease of troubleshooting. So in the case of bus topology, it is difficult to troubleshoot. Need to search for problematic node one by one. In the case of ring topology, it depends on backbone. If there is a backbone, troubleshooting is difficult. If there is no backbone, the focus is on two nodes not communicating. So it is also here very difficult to troubleshoot in the case of ring topology, whereas in the case of star topology, it depends on the host, which is also known as the controller. It is easier to repair the problematic host. However, if the nodes fail, then each node has to be searched. Mm, So if the controller is failed, then it can be it it can be troubleshoot easily, but if a node is failed, then we need to search which node is failed. Then the next point is ease of adding or removing nodes. So in the case of bus topology, it is very easy to add or remove any node or remove any computer from the backbone. Whereas in the case of ring topology, it is somewhat difficult to add or remove a computer from the ring, because it needs to rearrange the whole network. Whereas in the case of star topology, it finds it somewhat moderate between the uh, moderate to add or remove a node in the star topology. And the last point of difference is number of nodes when extending network. So number of nodes when extending network in the case of bus topology is many. In the case of ring topology, it is we can add only limited number of computers in the ring topology, and also in the star topology, the number of nodes are very limited. So these are the important points of differences between the popular topologies. So only 5 minutes are remaining. So I think all of you understand it. So I am just briefing the last slide of today's class. So this is, as you can see on your screen, this is the hybrid topology. So hybrid topology is basically formed by with the addition of two or more than two types of topologies. So here you can see on your screen that we are using three types of topology. So that's why its name is, as it is the combination of two or more types of topology, so its name is hybrid. So as you can see on your screen that we are using the bus topology, as there is a central backbone, and the node 1, the hub, and the node 4 are connected through the bus. Here you can find out that a hub is there which is working as the central controller. So it is here it is using as the star topology, and here you can find it a ring is formed for combining the node 4, 5, 6, and 7. So here we are using the ring topology. So as we are using bus, star, and ring topology, so that's why its name is the hybrid topology. And many a times the companies are using this hybrid type of topology. So all of you understand it till now? Just write in the chat box. So this is the introductory class in which we studied the computer network and its two main categories, like according to range and according to network topologies. So that's it for today's class, and in the next class we are going to study the internet and how it is been functioning, the importance of the internet, and the importance of internet, intranet, and the extranets also. So thank you very much for attending the class. Now you can leave this meeting.